Hi, welcome to a nostalgic ramble. Today is focusing on the department's paper 1 from November 2022, question 3, quadratic patterns. Let's see. It is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9. And the first term of the first differences is 7. Show that b is equal to 4. Okay, so the first term of the first difference that is the difference between term 1 and term 2. So if we have term 1, term 2, term 3, blah, 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 the first difference over here, we're being told that is 7. The second first difference would be this one, whatever. We don't care about that today. So I am going to get an expression for term 1 and term 2 using this formula here. So term 1 is 1 squared plus b times 1 plus 9, and that is 1 plus b plus 9, which is b plus 10. Right, and then term 2 is 2 squared plus b times 2 plus 9, which is 4 plus 2b plus 9, which is 13 plus 2b. Oh, let me be consistent. That is 2b plus 13. And we're being told that term 2 minus term 1 is 7. Right? So we can then write an expression for that difference using what we just worked out, expressions for term 2 and term 1. Right, simplify that, and we then have 2b minus b, which is b, 13 minus 10, which is 3. What do I add 3 to get 7? B must be 4. So we have successfully shown that b is equal to 4. Perfecto. Right. Another way we could have gone about it is, if you happen to remember that quadratic tree that I've shown a couple of times how to derive. I keep forgetting what the values are. I think these are the expressions for the first two terms, and then the first difference will be 3a plus b. And we know that a is the coefficient of n squared. In this case, it's 1. So then we would know that this is 3 times 1 plus b, which is just 3 plus b. And we've been told that that term is 7. So that would have been another way to arrive at that answer. But yeah, I am definitely a fan of not memorizing things that I don't absolutely have to memorize. So, right. So next part of the question says, determine the value of the 60th term of this number pattern. So first of all, we now know that Tn is n squared plus 4n plus 9. So the 60th term will be 60 squared plus 4 times 60 plus 9. And let's see what that is. So that is 3849. Okay, let me just check with the memo. Yes, we agree. Right, then the next question is, determine the general term for the sequence of first differences of the quadratic number pattern. Write your answer in the form TP is equal to MP plus Q. Okay, so we have the quadratic pattern that we've been given. I'm just going to generate the first few terms using this formula. So the first term is 1 squared plus, well, okay, so just write the formula again. Right, so the first term is 1 squared plus 4 times 1 plus 9, which I think is 14. Term 2 is 2 squared plus 4 times 2 plus 9, which is 4 plus 8 plus 9, 21. Term 3 is 3 squared plus 4 times 3 plus 9. So that's 9 plus 12 plus 9, which is 30. And let's just do term 4 for kicks. 4 squared plus 4 times 4 plus 9. So that's 41. So we have a sequence that looks like this. That's the quadratic pattern, right? And then we know that the first differences form a linear pattern, firstly because they told us so, right? Our TPP doesn't have a square on it. It's a to the power of 1. So we know it's a linear pattern, partly because of that, but also because in general for quadratic patterns, the first differences form a linear pattern. You can even, okay, I'm belaboring the point, but it is not difficult to prove. Let me know if you would like a special video for us to just look at the maths behind that. But anyway, so the first difference is 7, as we were told. The next one is 9. The next one is 11, right? So this is now the sequence that we're looking at: 7, 9, 11, and we want to find the general term. So there's a couple of ways that we can do this. So I'll do it using the arithmetic formula, but then I'll show another cute way that I would do it with my grade 8 kids once upon a time. So using the arithmetic formula, we know that, okay, A is 7, not to be confused with the A from the quadratic pattern. A as in the first term of the sequence, the arithmetic sequence, is 7. D is 2. N is just N. We don't care about N. N is whatever you want it to be. So for the general term, then we will have, we know that it's A plus N minus 1 times D. In this case, our A is 7. Our D is 2. So that will be 7 plus 2N minus 2. So that will be 2N plus 5. So that would be the general term, okay, except they said do it in terms of P. So instead of N, we would just say P. Right, so that would be the formula for that sequence. Another way that you can look at it is for your arithmetic series, right? 7, 9, 11. Okay, so you can see that each time this to go from one term to the next, you're adding 2. So this sequence is actually then related to the sequence of the multiples of 2, right? 2, 4, 6, 8, 10. Because, yeah, that goes up by 2 as well in the most basic way, right? So then I can look at this sequence and say, well, what transformation has happened for us to get this sequence? And you'll see that each time the difference between the corresponding terms is 5, all right? So this sequence, this guy over here, is just the sequence of 2 times whatever position you're looking at, right? 2 times 1 gives you 2, 2 times 2 gives you 4, 2 times 3 gives you 6. But if we want to get to this sequence, we then have to take this guy, and to each term, we just add 5. So then we end up with that sequence over there. So same answer, different ways of thinking about it. Right, I think there's one more question here. Okay, so same starting point, n squared plus 4n plus 9. Which 2 consecutive terms in the quadratic number pattern have a first difference of 157? Okay, so we now know that the first differences follow this sequence, right? So we can then use that to figure out, okay, the how manyth first difference is equal to this, right? So at what point is 2p plus 5 equal to 157? So we can then minus 5 on both sides, and we have 2p is equal to 152, and then divide by 2. So then we have p is equal to 76. So we now know that the 76th first difference is 157. So the next question is, well, which two terms does it occur between? So the first difference occurs between term 1 and term 2. The second first difference occurs between term 2 and 3. The third first difference occurs between term 3 and term 4. So the 76th first difference will occur between term 76 and term 77. So that is where the first difference will be 157. Let's double check with the memo. The memo says yes, between term 76 and term 77. So they have another way of approaching this, which is related. So they say we're trying to figure out, okay, term n plus 1 minus term n, we need that to equal 157. So we have a term and the term after that, and we want the difference between them to be 157. Or you could phrase it as term n and the term before it, right? We want the difference between term n and term n minus 1 to be equal to 157. Both of those would work. So then we find an expression for these terms using the rule. Okay, so let me just copy that rule actually, or just write it down somewhere. So that is Tn is equal to n squared plus 4n plus 9. So now we'll start with Tn plus 1. So that will be n plus 1 squared plus 4 times n plus 1 plus 9 minus, and then Tn is just, exactly as it is in the rule, right? And we need that the difference to be 157. So then we times it out. So we have n squared plus 2n plus 1 plus 4n plus 4 plus 9 minus n squared minus 4n minus 9. Right, so now we look for our common terms. N squared minus n squared, so those cancel out. 2n plus 4n, so that's 6n, minus 4n, so that takes us back to 2n. And then lastly, we have 1 plus 4, 5, plus 9, 14, minus 9, back to 5. Right, and what do we see here? Makes sense that we are seeing 2n plus 5 again, right? Because this is the expression for the first difference between a term and the term after it. So yeah, definitely makes sense to be seeing that guy again. So 2n is equal to 152, n is then equal to 76. So we know that it will be term 76 and term 76 plus 1, so term 77. And yeah, as a challenge to yourself, see if it would have worked if we had used term n minus 1 and term n instead. The hint is it should. Okay, thanks for popping by for a nostalgic chat. And I guess they're more nostalgic for me, not so much nostalgic for you if you are a matric student who is watching this to get ready for your exams later this year. So interesting channel title. Anyway, see you next time for another ramble.